Hi, quick video. I want to talk a little bit about prototyping. Most people, when you talk about prototyping, they think about these little solderless breadboards, and I mean, they come in various different styles and sizes. I mean, you get these ones here that, well, that's just small, but it's basically like this here without any power buses at all. You get them with power rail, one on each side. You can get them with dual power rails on each side. I mean, those are all fine and dandy, and then most people will talk about, oh, when you outgrow those, moving on and soldering your projects to make them a little bit more permanent on, things like these, and how you get these little jumper wires here to for your solderless breadboards and that. And I do use these quite often when building up circuits that I've prototyped and want to make a little bit more permanent, or sometimes if the design's simple enough and I have enough confidence. It's quite often misplaced confidence, but I'll just solder something up directly. Now, I had been using boards like this in various sizes pretty much exclusively, other than I didn't used to use these ones that are through-hole plated. I used just a single-sided board. They're a little bit cheaper, but I had problems sourcing them, and I can get these, these are cheap shipped out of China, so had been using those. Then I found these boards here, and I prefer a single-sided board for changing. These are a real pain to try and desolder from compared to a single-sided board. So I was looking around, and the other thing I don't like about these is sometimes I like the ones where you have some of the holes linked together, but those are also a little difficult to find. So I had heard of and read a couple times about strip board or protoboard, protoboard, and I finally found some, and I can get these relatively cheap. I think this particular size board here cost me, I think, somewhere like $1 or so a board. And basically what it is we've got all these lines coming across here of holes that are all interconnected with a strip of copper across them. And you just pop your components in there as you normally would, and you cut the traces where you don't want. Now, just grab some simple circuit here. So here's an example, and where I've actually used both types. So I've used point to point. This is basically what I used to use. It's just a single-sided version of one of these. So point to point, just to wire up a simple little oscillator here. And I just put some rubber feet on because I had it sitting loose on the desk. And then this is just a simple array of LEDs with just basic dropper resistors and some drive transistors there. But in this case here, flip it over, you'll see what I mean about cutting out, cutting the strips wherever I didn't want the electrical connection. And you can even see some of the little felt marks left here where I marked out where marking out for something anyways, where I was putting things across and cutting traces. This works really well. Now, to cut them initially, I read about there's some special tool you can get, but I'm not going to say it's expensive, but it's relatively expensive for a simple little tool. It costs you a lot more than a desoldering pump, for example, yet it's no more complex. So what I did is I just took an Olfa knife and I tried cutting, sort of angling the knife a bit and cutting the traces out. And that certainly does work, where you can cut a little bit of copper and then peel the copper off the board. I mean, the copper is well adhered to this board, but it doesn't take a huge amount of effort to pry it off. That's what I started to do, and that was time consuming, and you got to be really careful. I mean, it's easy, especially when you're cutting metal, to slip and wind up slicing into your hand. So I was reading around on some more forums, and somebody had suggested using a drill bit. And it's kind of awkward, you know, to get the big cordless drill in there and you're trying to drill these. And this is soft material. It's not fiberglass board, not the FR4 material like these are. So I drill into the material really easily, and you know, you gotta be careful. So I found it was easier to just use the drill by hand. And oh yeah, it's also forgot, a 3.2 millimeter drill works perfect for this. I mean, in Canada here, we sort of use both. A lot of your tools, it's more common to find imperial sizes. But I found ordering online, I could pick up what I'm sure is going to turn into a lifetime supply of drill bits for cutting my my strip board for, I think I paid around $3. Anyways, I just started using the drill bits by hand, and I just hold them in my fingers and sort of twist them. And that worked really well, because like I said, it doesn't take a lot to drill out these little holes here to make these cuts. And the problem with that I wound up having was that your fingers get really sore, you know, from the edges of the flutes rolling through. Unless you hold it right up at the end, and then there's a little less control, and your finger slides up and down, and you always seem to wind up finding the flutes, and you just wind up with sore fingers after you do a couple. So I mean, you know, I'll take a quick little count here, but there's so I made 24 cuts there with the drill, or with the drill bit. And you know, that's not a huge number. I have done more on a single board, but I was fabricating this in a hurry. And if I remember correctly, I did this one here. These are all white LEDs, and this is it's just a simple strobe light. And I was whipping them up for a child's birthday party. But I also, in that same evening, I also made 2 boards. There might have been slightly less LEDs on, but they were pretty close to the same configuration as this, slightly less densely populated with LEDs, with tricolor RGB LEDs. And I made 2 of those, and I made one ultraviolet, one board that had ultraviolet LEDs. So that was a lot, you know, when you add it all up, that's a lot to be drilling out. And there was, in this case, for the strobe circuit, it's just a 555 timer here. So I just did it point to point to wire that up. But the control board for the RGB LEDs, that was controlled with a microcontroller, and it went on another board, another piece of strip board. So there's even more holes to drill, and you know, you start drilling a couple hundred holes out by hand using your fingers get a little bit sore. So I learned to become really light with the drill. But of course, then you go and you do that, and you're messing around all the time using your drill. You go and kill the drill battery by the time you're done building all the boards, and you're ready to start drilling your holes through your metal chassis of whatever you're mounting it to, or you know, and then you wind up killing it. So that's not really an ideal solution either. So what I wound up, I came up with, don't know why I didn't think of it sooner, but I was at the thrift store, and they have old cordless drills in there all the time that have batteries that are won't take a charge anymore. They're dead. Some of them have even leaked. And nobody really wants these drills because, of course, it costs more to replace the batteries than what it costs to go out and buy a brand new battery. Or a brand new drill, sorry. So what I did is I picked one of these up, or I picked up a couple actually. I was able to get them dirt cheap. Paid like 25 cents or something. But once you get that out, you can quite easily remove the chuck from the drill. And I opened the drill up and removed the motor and salvaged that as well, and some of the gears, and then threw the rest away. But the chuck is the big thing. You take that chuck. It's just a small 3/8 keyless chuck, and the keyless ones are probably a little bit nicer for this purpose because they're usually coated with plastic or have a plastic finish on the exterior. And I just put one of the 3.2 millimeter drill bits in there and just sort of tightened it up a bit, snugged it up as best I could. It's a little bit more awkward to tighten that the chuck up when it's not in the drill for some reason. Or at least I did, but maybe I'm just gibbled in and can't figure it out. Anyways, once I did that, now I've got that nice big heavy weight, and the nice thing is my drill bit was not rolling around all over my workbench and, flopping down wherever, rolling off, and then I got to stop and try and hunt for it and find it on the floor, pick it up. It saved the fingers, you're not having to get my fingers caught up in the flute at all of the drill bit. And because it's got that... instead of grabbing that little tiny drill bit, grabbing something like this and turning it, now I'm grabbing, this circle. I just hold it in the palm of my hand and just takes a couple turns and boom, you got your holes cut. And it just works great. And I found in my fingers, for whatever reason, turning forward was easy. Turning back is a little bit harder. With the chuck on there, it's easy to do both ways, so you can give a little turn backwards to clean up, because you're going to get like little bits of burrs coming over, and you don't want, one trace shorting to the next. So that can just help a little bit. Just going to show there is a few different ways of mounting stuff. So even though you're using, these things like the strip board and that, you use these pin headers. There's Arduino unit there. This here is actually not soldered in yet. Probably shouldn't have pulled that out because now I'm not sure where I had it, if I had the pins lined up or not. The other thing too, this reminds me of, is these terminal blocks are great. I love them for making connections to parts. So in this case, that's a temperature sensor, and I put a terminal block in there so that I could run wires on this and have it run off and be a remote probe. These can be a little bit stiff. They'll just fit, but I have had a few slightly heavier terminal blocks that I've salvaged out of parts that I can't get to fit in here. And, it's a good idea to have an array of different sized drill bits, and sometimes you got to drill those holes out ever so slightly. And what I do when I'm not trying to remove the copper is I actually drill from the top down ever so slightly, and the copper has a tendency to lift up a little bit. So then when I stick the part in, I can get that copper trace, you get that fill in there just to get a good blob around it. Because you actually do wind up breaking the trace, so you have to make sure you get solder on both sides of the parts. Probably made no real sense the way I said that. Okay, that's it for now. Till next time.